Good morning. This is Arsenio Iguston Jr., the reporter of Advanced Calculus. First problem, evaluate each integral by separating the fraction and using substitution if necessary to reduce it to standard form. To evaluate the integral from 0 to pi all over 4, 1 plus sine x all over cosine x squared x times dx. Simplify the integrand, 1 plus sine x all over cosine x squared x times dx equals 1 all over cosine squared x plus sine x all over cosine squared x. The identities are 1 all over cosine squared x equals secant x squared x. Then sine x all over cosine squared x equals 1 all over cosine x times cosine x equals sine x equals cosine x times 1 all over cosine x. The integrand secant squared x dx equals tangent x. Integrate each term. The integral from 0 to pi all over 4 secant squared x dx plus the integral of from 0 to pi all over 4 tangent x secant x dx. Integrating secant squared x, the antiderivative of secant squared x is tangent x. Integral secant squared x dx plus tangent x. Evaluating this from 0 to pi all over 4, we get that tangent x from 0 to pi all over 4 equals tangent pi all over 4 minus tangent 0 equals 1 all minus 0 equals 1. Integrating tangent x secant x, the antiderivative of tangent x secant x is secant x. Integral tangent x secant x dx equals secant x. Evaluate this from 0 to pi all over 4, we get that secant x from 0 to pi all over 4 equals secant pi all over 4 minus secant 0 equals square root of 2 minus 1. Then combine the results, adding the results of the two integrals. 1 plus square root of 2 minus 1 equals square root of 2. Therefore, the value of the integral is square root of 2. Then second problem, evaluate the integrals. Integral from negative pi to 0 sine 3x cosine 2x dx. We can use the product to sum identities in trigonometry. Specifically, we use the identity sine a cosine b equals 1/2 times sine times a plus b plus times a minus b. For our integral, we set a equals 3x and b equals 2x. Sine a cosine b equals 1 times sine times 3x plus 2x plus sine times 3x minus 2x times 1/2 times sine 5x plus sine x. So the integral becomes integral from negative pi to 0 sine 3x cosine 2x times dx equals integral from negative pi to 0 1/2 times sine 5x plus sine x times dx. This can be separated into two integrals. Integral from negative pi to 0 sine 3x cosine 2x times dx equals 1/2 times integral from negative pi to 0 sine 5x times dx plus integral from negative pi to 0 sine x times dx. We evaluate each integral separately. First, considers the integral of sine 5x. Integral from negative pi to 0 sine 5x times dx. The antiderivative of sine 5x is negative 1/5 cosine 5x. So we have integral from negative pi to 0 sine 5x times dx equals negative 1/5 cosine 5x from negative pi to 0. Evaluate at the limits. Negative 1/5 cosine 5x from negative pi to 0 equals negative 1/5 cosine 5 minus times negative 1/5 cos times 5 times negative pi equals negative 1/5 cosine 0 plus 1/5 cosine negative 5 pi equals negative 1/5 times 1 plus 1/5 times negative 5 equals negative 1/5 minus 1/5 equals negative 2/5. Then combine these results, we get that integral from negative pi to 0 sine 3x cosine 2x times dx equals 1/2 times negative 2/5 plus 0. Thus, the value of the integral is negative 1/5. Then the third problem. Volume by cylindrical shells. Use the shell method to find the volume of the solids generated by revolving the regions bounded by the curves and lines about the y-axis. Y equals x. Y equals negative x all over 2. X equals 2. Where f of x represents the heights of the shell at the given x value. Given curves and lines, y equals x, y equals negative x all over 2, and x equals 2. Well, first find the intersection points. First, intersections of y equals x and y equals negative x all over 2. X equals negative all over 2 to 3x all over 2 equals 0. 2x equals 0. Then second, intersection of y equals negative x all over 2 and x equals 2. X equals 2. So, we have the bounds for integration 0 lesser than equal to x lesser than equal to 2. Now, we'll find the height of the shell at each x value at x. The height of the shell is f of x equals max of x comma minus pi all over 2. Now, let's integrate using the shell method formula. V equals 2 pi integral from 0 to 2 x times max of x comma minus x all over 2 times dx. This integral represents the sum of the volumes of the infinitesimally 10 cylindrical shells, each with radius x and height max of x comma minus pi all over 2, as x varies from 0 to 2. We can split the integral into two parts based on the maximum value function. For 0 lesser than equal to x lesser than equal to 1, f of x equals x. For 1 lesser than equal to x lesser than equal to 2, f of x equals negative pi all over 2. V equals 2 pi integral from 0 to 1 x squared dx plus integral from 0 to 2 x times negative pi all over 2 times dx. Now, let's compute each integral. Integral from 0 to 1 x squared times dx equals x cubed all over 2 from 1 to 2 equals 1/3. Integral from 0 to 1 x times negative pi all over 2 times dx equals negative x cubed all over 2 from 1 to 2 equals negative 76. Let's substitute these results back into the formula. V equals 2 pi times 1/3 minus 76 equals 2 pi times 26 minus 76 equals 2 pi times negative 56 equals negative 53 pi. So, the volume of the solid generated by revolving the region by the curves and lines about the y-axis is negative 53 pi. That's all. Thank you and God bless.